So today we are talking about parallel lines and proportional parts of triangles, and again we're still dealing with similar triangles. So this theorem states that if a line is parallel to one side of a triangle and intersects the other two sides, so in this case BE is parallel to CD and BE intersects these other two long sides, and then it divides the sides into segments of proportional length. So AB is this longer part of that long side and BC is that short part. AE is the longer part of that long side and ED is the short part. So that's what this proportion is saying up here. Our first example on this page, however, does not deal with that parallel line portion of it. We only need the parallel lines here to prove that this angle and this angle are congruent, and then angle A is congruent to itself. So we can use angle-angle similarity to show that ABD, this small triangle up here, is similar to ACE, that big triangle there. So to set up a proportion here, we could say 5 over x, since 5 is the side of this triangle and x is that long side, equals 3, which is this side here, over not 7 here, but over 10, because 10 is this big side AC, so it'd have to be 3 over 10, not 3 over 7. So be careful with that. We need to add these sides together to get the proportional side. So then when we find our cross product, multiply 3 and x and 5 and 10, we'd get 3x equals 50. So when we divide off our 3 here, we get x equals 50 over 3. This next problem here is using the parallel lines and proportional sides. This should say sides theorem. So this we could say 3 over 7 equals 5 over x. You see how this is set up differently than the problem before? Here we have AB, which is part of it, over BC, which is the other part, and AD, which is part of it, over DE, which is part. So now we get 3x equals 35. So x would equal 35 over 3. All right, so we get different things here depending on how this problem is set up. So this next one is what's called a corollary. So it's not a direct theorem, but it's a corollary that we can use off of our previous theorem we discussed. It says if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. In this example, it's saying this part here, AB over BC equals EF over FG. So this is similar to the one we used before, but just slightly different. So here it's asking, are these lines parallel? We could say this first one, we'll call this line A, is parallel to B, yes, by alternate exterior angles. 1 and 2 are alternate exterior angles just in these first two parallel lines. And then here with B and C, these two are parallel to each other because 2 and 3 are corresponding angles. So if A is parallel to B, B is parallel to C, A is parallel to C, and they're all parallel. So we can say, yes, all the lines are parallel. Now to solve for x, we'd set up a pretty simple proportion like we've done before. We can say 8 over 12 equals 9 over x. When we cross multiply, we get 8x equals 108. We divide both sides by 8. I would get x equals 27 over 4. 27 over 2, excuse me. Sorry, 27 over 2, so 13 and a half. If you got a decimal approximation, it'd be 13.5. So that's what we get for x in that situation there. So this corollary based off of the one we have before is saying if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So this first transversal here, we said AB's congruent to BC, so we can say EF is congruent to FG. So if you want to mark those in, that might be helpful for your memory there. And then we can do that the same on this diagram. So if these two are congruent, these two are also congruent to each other, not to the other ones. So here we can say 12 minus 3y equals 16 minus 5y. If we add the 5y to the other side, we get 12 plus 2y equals 16. We subtract the 12 from both sides. We get 2y equals 4, so y equals 2. Okay. Then we can do the same thing here, setting these two x parts equal to each other because they're congruent. So we can say 1/4 x plus 6 equals 2x minus 29. I'm going to subtract the 1/4 x over to this side, so I get 6 equals 7/4. If you have 1.75x, that would work as well. So 7/4 x minus 29. Now add 29 to the other side. We get 35 equals 7/4 x. So now remember, to get rid of a fraction, one of the easiest ways is to multiply by the reciprocal. So in this case, we get 20 equals x. Okay, thanks guys. I will see you on Monday.